Hello friends, in this video we are going to learn two-dimensional array. So if we declare a two-dimensional array as int a of 4 and 5, 4 and 5 are the size of the array. In two-dimensional array we have to use two pair of square braces. So 4 represents number of rows and 5 represents number of columns. You can see column 1, column 2, column 3, column 4 and column 5. There are 5 columns. The index starts from 0. If you say 5 as a size, the index will be 0 to 4. If you say 4 as the size, the index will be 0 to 3. You can see there are 0 to 3 rows. That is 4 rows totally, 0 to 3. So this is the location number. So every location has a number. So it will be stored in the memory, that is the primary memory, RAM. And the location we can access using the location numbers, that is the index numbers a of 0, 0 to access the first row, first element in the first row and first column. And the second element in the first row and second column is a of 0 of 1. So this way we can use a of 0, 1 to access the element at the cell, first row, second column. To initialize a two-dimensional array, so we can initialize in the program like this. We can have flower braces. We can arrange like this. This is a 3 cross 3 array, or you can call it as a 3 cross 3 matrix. So we do most of the matrix calculation using two-dimensional array. So we have initialized value a of 0, 0, a of 0, 1, a of 0, 2, a of 1, 0, a of 1, 1, a of 1, 2, a of 2, 0, 2, 1, 2, 2. So these are location numbers, whatever I say. So this is the value in the a of 0, 0. This is the value in the a of 0, 1. 1, 3 is the value of location a of 0, 2. So this way we can initialize a two-dimensional array. We can have a two-dimensional array of 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5. So to output the two-dimensional array in the program, we can do this. We can use a printf statement. Then a of 0, 0 will be the value at a of 0, 0 will be printed at the place of percentage, the first percentage d. A of 0 will the value of a of 0 will be 0, 1 will be printed here. A of 0, 2 will be printed here. Similarly, a of 1, 0, a of 1, 1, a of 1, 2, a of 2, 0, 2, 1 and 2, 2 will be printed in the respective locations. So we can also initialize a two-dimensional array dynamically taking the input from the user using a for loop. You can use any other loop. I just used a for loop. For loop is the best friend for arrays always. So I'm using I as a loop variable. So initialized it to 0, I less than 3, that is the loop works till I 0, 1, 2. So we have one more loop, inner loop here, j loop. So the outer loop is for rows, number of rows, iterating through number of rows. The inner loop is for iterating between the columns. So first column, second column, third column. So we take values for first when I is equal to 0, 0 less than 3 is true. And next the condition is checked, j is equal to 0, j is initialized to 0, j less than 3, 0 less than 3 is true. Now I and 3 are 0, 0, so I and j are 0, 0, so a of 0, 0 will be taken input. After this scanf statement is complete, next it goes to the j++, that is increments the loop variable. Now j becomes 1, so again goes to the condition statement, 1 less than 3, so is again true, and again the input is taken for a of 0, 1 because I remains 0, j incremented to 1. So a of 0, 1, the value for a of 0, 1 is taken from the keyboard. And then it goes to the increment statement j++. So now j becomes 2, 2 less than 3 is true again. And now the value is taken for a of 0, 2 because the I remains 0 and j increment to 2. So value for a of 0, 2 is taken. And after that j increments to 3 and 3 less than 3 is false. So comes out of the inner loop and goes to the increment statement in the outer loop. So now I increments to 1. So once the I increments to 1, 1 less than 3 is true, and again the next for loop statement j is again initialized to 0. So now I is 1 and j is 0. So j is 0 less than 3 is true. So a of 1 and 0, a of 1 0, the value is taken for the location a of 1 0, and next j increments to 1 less than 3 is again true. So now a of 1 1, the value is taken for the location a of 1 1, again j increments to 2. So 2 less than 3 is true. Now I remains 1, j incremented 2. So a of 1 2, the location a of 1 2, the value is taken for the location a of 1 2, and then j increments to 3. 3 less than 3 is false. Again it comes out of the inner loop and goes to the outer loop. I increments to 2. So 2 less than 3 is true. Now I is 2. So j initialized to 0 again. You can see here, and now 0, j is 0, I is 2. So a of 2 0 is taken value. The value is taken for a of 0 2 comma 0, and then j increments to 1. Then 1 less than 3 is true. I remains 2. A of 2 comma 1 is taken in the next iteration, and then j increments to 2. 2 less than 3 is also true. Again now a of 2 2 location gets the value, and j increments to 3. 3 less than 3 is false and comes out of the loop, and I increments to 3 again in the outer loop. 3 less than 3 is false. It comes out of the outer loop, and the program execution jumps after the two to the statements which are after these for loops. This way we can take input from keyboard to a two-dimensional array. So we can give output similarly. First we can print when I is equal to 0, j increments from 0 to 1, 0 1 3 2 0 1 2, and it will be printed. Next when I becomes 1, a of 1 comma 0, a of 1 comma 2, a of 1 comma 0, a of 1 comma 1, and a of 1 comma 2 will be printed because j is incrementing from 0 to 2, and then I increments to 2 again, then j increments from 0 to 2 again. So we will be printing the value of a of 2 comma 0, 2 comma 1, and 2 comma 2. So we will see that pictorially. Here you can see in the first for loop, that is the I loop, I is equal to 0. So it goes inside the I loop, and then j loop is executed 3 times for the values j is equal to 0, j is equal to 1, and j is equal to 2. So first inner loop, when I is equal to 0, j executes for 0, that is a of 0 0 value will be taken. Next j increments to 1, so a of 0 1 will be taken. So inner loop executes again, and j becomes 2. A of 0 2 will be that value will be taken for a of 0 2. So once the j increments to 3, the inner loop becomes false. The condition of the inner loop becomes false. So it comes out of the inner loop and goes to the outer loop. The outer loop I increments to 1 next. So when I increments to 1, again it goes inside the inner loop. So inner loop, now I is equal to 1, j initialized to 0 again. So it increments from 0, 1, and 2. So 3 times the j loop executes. After that j becomes 3 and comes out of the loop and comes to the outer loop. The outer loop I increments to 2. So in this case again, when I is equal to 2, j loop executes 3 times and this. So whenever the values, you can see a of 0, a of j, I comma j, so I is 2 and j is 0, the value will be taken for a of 2 comma 0, and the next loop I is 2, j is 1, so value will be taken for a of 2 comma 1, and next in the last j loop, j will be 2 and I will be 2, so a of 2 to the location the value is taken. So this way we can take input values from the user or give output values from the two-dimensional array. So we will see some examples. So we do a matrix addition here. So in this addition we have a matrix A and matrix B. So we want to add matrix A and matrix B and provide the output to the matrix C. So the respective locations, so this will be a of 0 0, a of 0 1, a of 0 2. So a of 0 0 should be added to b of 0 0, a of 0 1 should be added to b of 0 1, a of 0 2 will be added to a of b of 0 2. Similarly, it will be stored in the c of 0 2. A of 0 0 added with b of 0 0 and will be stored in c of 0 0. So similarly, we can add this in a for loop. So we will see this program, entire program looks like this. It has 3 matrix C, A, B and C. So we have to take input for the A first, A matrix. So we use the same input loop, two loops, I and J loops to take input for the A matrix A. So next we will take input to the matrix B. So we have to use ampersand B here. So now we are taking input for the B loop, B matrix, and then after taking both the input in the third for loop, in the third pair of for loop, we will calculate the C, the C matrix by adding every location. So when I is equal to 0 and J is equal to 0, A of 0 0 will be added with B of 0 0 and given to C of 0. Next, J becomes 1. So A of 0 1 will be added to B of 0 1 and will be given to C of 0 1. This way we can add all the elements of the two arrays and keep it in a third array, that is the third matrix. So to output we can use similarly a pair of for loop and print. So here I'm using simple 3 cross 3 matrix. You can use 4 cross 4, 5 cross 5 depending upon the support of the compiler. So we'll see one more example. So in this example, we have to add the elements, the principal diagonal elements of a matrix. If we want to add only 3 elements, how can we do? So we'll see that in a program in a few minutes. So in the third example, we have to add the secondary diagonal elements. That is the elements 2 2. That is location 0, 2, 0, 2, 1, 1 and 2, 0. So we will see how this can be done in a few minutes in a program. So in the example 4, we want to add individual row elements and give output for each row. We will see how this can be done, and in the last example, we will see adding individual column elements and giving 3 different column totals. That is sum of each individual column. So we will see some programs. So how to initialize this program shows the initialization and output of array. So we can initialize using the writing the code inside the values inside the program like this, and we can print those values using a printf statement. You can see here we are printing A of 0 0 here, A of 0 1, A of 0 2 in this place. So this way we can print, it's again depends on you how you format it. We can print everything in one line, but if you print like this, it looks like a table or a matrix. So we'll compile this using Alt F9. You can see we are using a 3 cross 3 matrix here. Do Alt F9 to compile the program and do Control F9 to run the program. You can see the output here, exactly same what we have given. Everything. So this way we can give the values inside the program and print those values, but it will not be dynamic. It will be a static value. N number of time you execute, it still remains the same values. You have to change it in the program and then compile. So what you can do is you can use a for loop to take dynamic values from the user. So we are using the for loop to take value for matrix A and print the value of matrix A in the next pair of for loops. So I will do Alt F9 and I will do Control F9. So I will give output. So you can give it in a one line. So but I will give it in 3 different lines because we are using a 3 cross 3 matrix here. So you can use 4 cross 4, 5 cross. I'll show you in few moments how you can change dynamically. So this will be the matrix. So I can enter in a different line. You can enter everything in the same line. It doesn't matter. So I give the output like this. So I get output like this. So even if you give output in a single line, so I gave it in a single line and press enter. You can see it gives in 3 different lines because we have formatted. We have given /n after every printing each row. So for every row we are printing, for row 0 we are printing all the 3 values of columns. So we'll see this in a minute. So if you want like dynamically decide the number of rows and columns, you can say, you can give in generic 10, and you can take a value n from the user. Say printf enter rows and column size. So what you can do is you can have different size of matrix also. I will do row, comma, column. So this will be our row and this will be our column. Row, column. So the user has to enter values. So I'll explain this in a moment. Percentage %d. I do percentage %d. So we will take two values, rows and columns. So in this case, it can be a 2 cross 3 matrix or a 3 cross 2 matrix. It's not a square matrix. So we will say ampersand row, comma, ampersand column. So now we'll compile this program and run the program. So it says enter row and column size. I'll say 3, 2 cross 2 matrix. So 3 rows and 2 columns. 2 columns I'll give you can see it prints 3 cross 2 matrix. Now again I'll run the program to control it. Now if I say 4 and 3, so 3 columns and 4 rows, I say so you can have float matrix, you can have a character matrix, but we only use we can use anything. Here I'm using only integer matrix or integer two-dimensional array. You can use any one. So I thought it would be simpler to explain so that you can understand easily. So we have 4 rows and 3 columns. You can see we get the same exact value. And this way we can have dynamically give the size of the matrix. So here we have one matrix of type integer and all the variables row, column, I, j. So these two I am using it for loop variables and these two for defining the size of the matrix or the two-dimensional array. So here first we are taking the size from the user for row and columns. So depending on that, so for first row we take column all the three n number. See, if we are using a 4 cross 3 matrix, so then for first row we are taking three values for, because 3 columns will take 3 values, so the loop will be running 3 times. So similarly, depending upon the number of columns, the inner loop will be running. Depending on number of rows, the outer loop will be running. So totally the number of loop iteration will be row into column. If you are using a 3 cross 2 matrix, then it will be 3 twos are 6 total iterations. So similarly, we can output the value using the same row and column as condition, using in the row and column in the condition. So we'll see one more example. In this example, we want to do sum of 2 matrix. So we have matrix A of 3 cross 3, matrix B of 3 cross 3, C of 3 cross 3. We should have a same size of our matrix or the 2D array to add exactly. So before adding, we'll check a condition. So first we'll take input. So we have given 3 cross 3 in a code, but if you take dynamically like row and column, as we did in the previous program, then you have to check the condition something like if row 1, row 2, I'll give that example here. Before that, we'll compile this. You can see first we'll take input for the A matrix. Next, we'll take input for the B matrix. In the third pair of for loop, we are adding the A and B matrix and giving it to the C matrix. So then we are printing the C matrix. So it's very simple. You have to use a for loop, pair of for loops to use. So when I is 0 and J is 0, A of 0 0 will be added with B of 0 0 and given to C of 0 0. And I is equal to 0 and J is equal to 1. So A of 0 1 and B of 0 1 is added and given to C of 0 1. Similarly, we can add all the values of matrix of A and B and give to the elements of the C matrix. So I'll compile this and run the program. Now if I say it's a 3 cross 3 matrix, so I give a matrix B. Now I'll give a matrix give a matrix A. Now I'm going to give matrix B. You can see it gives 4 4 4. So it is better that you use some statements here so that you'll understand what exactly to do. You always give the printf statement so it looks easy for the user to enter values. Because we have written this program, we know what exactly we need to give, but if some other person wants to execute the program, he'll not be able to know what exactly the code is, because if you're giving him an executable file, he'll not be able to enter 3 cross 3. You have to mention exactly what matrix you are using. If you are using dynamically taking input values, then you don't have to mention 3 cross 3. You have to say enter the row and column size. So we say enter 3 cross 3 matrix values for 3 cross 3 matrix A. Similarly, we can write it for B. So then we can calculate everything value here, and before giving output we can say sum of two matrices are. So always suggest you to give /n in the all line so that a new line character is added so that the output looks neat. /n. I'll do Alt F9 and Control F9. In my case, it says enter the equals to matrix. It says enter value for matrix B. And you can see it printing fine. So because of there's a space between after all new line character, that's the reason the output is not pretty clean. I'll come and run the program. Now you can see now you can see it prints the value like this. So you have to give questions like this. If you want a dynamic input from the values, then you can add something called row 1. So because to add you don't have to add a row, use row 1 or row 2. You can say row 1 column because the size of the matrix should be same to add the two matrix. So you can say row and column, and you can say tell the user to enter the row and column values. enter row and column size, scanf, %d, comma, ampersand, row, comma, ampersand column. Now we don't need to say 3x3 matrix because the user will be knowing what's the size. Now we have to say, we have to iterate the loop until the size of the row and column, row, column, and again row, column everywhere. You have to change row, column. So we change it everywhere. The user enters row and column. So here we can say in generic 10. So we'll allocate so many locations so that we can use it at least 10, a maximum of 10 actually. We can use maximum of 10 cross 10. Now I'll do Alt F9 and I'll do Control F9 to run the program. So now I say 2x3 matrix, 2 rows and 3 columns. So now I can say 1, 2, 3, 2, 2, 2. Oh, sorry. Now you can see it takes exactly so many values. It's not waiting for the third row, 3x3. It's exactly taking the number of row and column we mentioned. Now I say you see it exactly adds the value. So again, it gives wrong values because we are trying to print. You have to give row. I missed this for loop. We'll compile and run the program. Now if I give, okay, we need to give the size first. We give 3x2 matrix, 3 rows and 2 columns. And now you can see it gives the value as 3x2. So this way we can mention the size dynamically. So this is a difference between two matrices is simple. All you have to do is change the minus symbol. Instead of plus, we just change it to. So it will be A minus B, matrix A minus matrix B. So I'll do Alt F9 to compile this program and Control F9 to run this program. So I'll give it's a 3x3 matrix. I'll give 1. So I'll give the matrix 2, the matrix B. You can see the size of the B, the values in the B are greater than, so we get a negative value like this. So this way we can use subtraction. We can do subtraction on matrix. The sum of all the elements in a matrix. So how can we do this? So it's very simple. Taking one by one element in the matrix. We have one matrix here, A of 3, 3. We have initialized a variable sum is equal to 0, and we have taken two loop variables. So similarly, we use loop variables, a pair of loop for everything in the matrix. For addition, for input of array to output of array, we'll use a pair of for loop if it's a two-dimensional. If you're using a three-dimensional array, then you have to use 3 for loops. We are not going to discuss about three-dimensional arrays here. So we'll take input for each values of matrix. So here we are using a simple 3x3 matrix. So we can take values for A of 0, 0, A of 0, 1, 0, 2, A of 1, 0, A of 1, 1, A of 1, 2, A of 2, 0, 2, 1, and 2, 2. So many locations we can take value using this for loop. So you should be very thorough with the for loops. So if you don't remember the for loops, so you can go back to the loops videos and check how exactly the loop works. So again, after that, we add all the elements one by one. So initially sum is 0, sum is added with a of 0 0, and next sum is added with 0 1. Sum is added with 0 2. So sum keeps on increasing the value by adding every time it takes the value from a location e of 0 0, e of 0 1, and it will be added to sum and given to the saved in a sum. So this way we can add all the values in a matrix. I'll do Alt F9 to compile this program and Control F to run. So I'll give it's a 3x3 matrix. So I will give you can give it in one line, but still it looks pretty fine if you give it in a different line. You can see we get 45 as our output. So this way we can add some of all the elements of a matrix. So some of principal diagonal elements. So in this, how do we consider a principal diagonal element? To add the principal diagonal elements, we have to check a condition. So how exactly we can check this condition? You can see when I is equal to 0. So we know that when the principal diagonal elements are there, I just type it here. If the location 1 we have 0 0 is the location 1 number, 0 1 and 0 2. 0 2 is the location number. So we can see here in the 3x3 matrix, in the 3x3 matrix, the location numbers you can see 0 0 0 1 0 2 1 0 1 1 1 2 2 0. So you can see here in the principal diagonal elements, the values of row and column are same, so equals. So if we check this condition, if I and j are equal, then only add the elements. So the for loop will be iterating like this. It will go here, it will name the next loop, it will go here, and the next loop will go here, and then it will go to the I loop and start j is equal to 0, and next goes here one by one. But it should add only these elements. So we will add only when the I and j are equal. So here you can say I and j are equal, I and j are equal. Here also I and j equal. So we will add the values at these locations only when I and j are equal. So we will use this in our program. I'll just comment this out. This is not a part of program, so we'll comment this. So now if I compile, I'll do Alt F9 and do Control F9. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 9, press enter, it should add 1, 5 and 9, it should give 15. We can see here it gives exactly 15 value. So similarly, so we will execute one more program. We'll do Control F9 and we give 3, 3, 3, okay, 3, 3, 4, 1, 2, 5, 7. So you see the value should be 3 plus 2 plus 3, that should be 8. So we get 8. So this way we can add only the principal diagonal elements. So whenever the I and j are equal, we'll take the value and add it to the sum. Otherwise we will not. See here we are checking condition. If I is equal to j, then only add the value at the location, or else just skip this number of statement and go to next j, increment the j and go to the next location. So this way we can use a program to add only the principal diagonal elements. So next we will see how to add second diagonal elements. So you need to be a little careful here because this expression will give you exactly how it can be done. So 0 0 0 1 0 2. One zero, 1 1, 1 2. So 2 2 0 2 1 2 2. So these are the location numbers of a 3x3 matrix. So we have to add this location, and this location. You can see there's no much relation. There's no relation between this, like whether they are equal or less. So how to create a relation here is, so what we can do is we can write something like this: j is equal, when j is equal to 3 minus I. So initially j is equal to 0. So I is equal to 0 in the first time. So 3 minus 0 will be 0. So we have to add the elements when I is equal to 0 and j is equal to 2, and I is equal to 1 and j is equal to 1, and I is equal to 2 and j is equal to 0. So what we do is we write here when j is equal to 3 minus 0 in the first time, I is 0, 3 minus 0 is 0, 3 minus 1, 2. So when j is 0 and I is 2, it will not be printed. So when j becomes 1, again 3 minus 1 is 2, 2 minus 1, 1, and 0 is, j is 2 actually, j is in the first time. Okay, we'll do it again. So initially j is 0, first time I is 0, j is 0. So now 0 we are checking with 3 minus 0, that is 3 minus 1, 2. So 0 equal to 2 condition fails, and so the value at this location will not be added. Next, I is equal to 0, j becomes 1. So we are checking 1 with 3 minus 0, again 2. So then also it will not execute because j is now 1 and I is 0, 3 minus 0 is 3, 3 minus 1, 2. So 1 is not equal to 2. So this condition here, this location will also not be added to sum. The next, now j will become 2. So we'll check in 2 with 3 minus 0. So 3 minus 0 is 3, 3 minus 1 is 2. So now j is also 2 and this expression also evaluates to 2. So then at this location the value is taken and then added. So in the next, j increments to 3 and 3 less than 3 is false. So it goes out of this for loop and I is incremented to 1. So again j is initialized to 0 because 1 less than 3 is true. I is becomes 1 and 1 less than is true, 3 is true. So it executes the for j loop again from first. So j becomes 0 again, 0 less than 3. So now j is 0, 3 minus 1 is 2 because I is 1 right now. So 2 minus 1 is 1. So in this also case it will not execute because 0 and 1 are not equal. So next j increments to 1. So now we are checking 1 with I is also 1, 3 minus 1 is 2 and 2 minus 1 is 1. So when j is equal to 1, I is equal to 1, this statement becomes equals because j is 1, 3 minus 1 is 2, 2 minus 1 is again 1. So j is also 1 and this expression is also 1. So this becomes true, and in this location whatever the value is there, that it will be added to the sum. So this way we can use this expression to add the secondary diagonal elements like this. So when I is equal to 2, j is equal to 0, you can see when I is equal to 2, 3 minus 2 is 1, 1 minus 1 is 0. So 0 equal to 0 when j is 0, and this expression also gives when I is 2, this expression gives 0. So that time this location value is also added. Similarly, all these three values are added using this expression, and we get a secondary diagonal element, sum of the secondary diagonal elements. So we compile this program and run the program using Control F9. I press 2, 3, 4 values. It's a 3x3 matrix. So we should get a value of 4 plus 2 plus 2 is 8. So we get 8 as a output. So we'll do it again, Control F9. This time we'll give 0, 0, 1, 0, 1, 0, 1, 0, 0. So now you can see we get 3 as output. So this way we can add secondary diagonal elements. So sum of row elements, how can we do that? So we will take similar, we'll declare a array of 3 cross 3. So we'll have a sum variable of 0. So now you can see we take input of array using the same pair of for loop. So we can take values for all the elements of matrix A. So then now, so in the second for loop, we are using the for loop to calculate and add together. So when I is equal to 0, this is the first row execution. The first row execution, sum is equal to 0. So the for loop starts for the columns. So when I is equal to 0, 0, 0, comma, j is equal to 0, it's 0, comma 0, and j increments to 1 in the next loop, and j increments to 2. So in this loop, the value of the I and j is 0, comma 1, 0, comma 2, and 0, comma 3. This is one row elements. So we will be adding all the elements. So once this loop completes, it goes to the next row. That is when I increments to 1, it goes to next row. Before that, what we can do is we can print the value of sum. So we get one row sum completely, the first row sum completely. And then I increments to 1. So we'll make that sum 0. So that we want the next row total value in the sum variable. So whatever we already calculated, we'll make it 0 again. And now the I is 1, so it's the second row elements will be iterated using j. J as 1, comma 0, 1, comma 1, and 1, comma 2 will be added to sum, and it will be printed here. So next again, I increments to 2. So sum we are initializing sum to 0 again. So again, now I is 2, 2, comma 0, 2, comma 1, and 2, comma 2 will be added to sum here, and it will be printed. So we can print the sum value of sum of each row value after the j loop. So once one j loop is completed, one row is completed. So next time the I increments to 1 and next j loop is executed, so one more row is completed. So next I increments to 2 and for loop is j loop is executed, the third row is completed. So we can print sum after every j loop, every inner loop, so that we get sum of each row. I'll compile this program. I'll do Alt F9, I'll do Control F9. So 1, 1, 1, 2, 2, 2, 3, 3, 3. So you can see we get sum of row 0 is 3, sum of row 1 is 1. So here we are printing in the place of percentage %d here, we are printing the value of I, the row number. So and in the place of this percentage %d, we are printing sum. So we are printing after every j loop. So we get sum of first row, sum of second row, sum of third row. So we can also add the sum of column elements. So we can add the sum of column elements. So here you can see I'm printing j, comma I. So here, so for each j, the value will be added separately. So I'm printing, I just changed this j and I've interchanged the values. So it will add, in the first j loop, it will be adding 0, comma 0 and j increments to 1. So 1, comma 0 will be added. The value at a of 1, comma 0 will be added, and a of 2, comma 0 will be added to sum and printed. Similarly, so we can add the column elements after every j loop. So all we have to do is interchange the j and I. Alt F9, Control F9 to run the program. Now I'll say 1 space 2 space 3. Now you can see it adds 1 plus 1 plus 1 is 3, 2 plus 2 plus 2 6, and 3 plus 3 plus 3 9. So this way we can add sum of column elements and row elements using a program. It's very simple. Friends, we can do a lot of calculations using matrix. We saw many examples in this program. We'll see more in upcoming programs. Thank you for upcoming videos. Thank you for watching this video.